sparkling water, mineral water, plastic cup, and resins.
Now we are going to see the difference when we use the tap water and the sparkling water. So first, we are going to pour the sparkling water into the cup. So we need to pour the sparkling water into the cup. Okay. And then, let's see the difference when we put the raisins in the tap water and the sparkling water. Nothing happened. The raisin is not dancing here in the tap water, okay? So when we put in the sparkling water, see, it started to dance. Can you see these kids? Oh my god, this is so amazing, right? So, let's do it together with us. This is your water.
Thank you, teacher. Okay, so what will we do, teacher?
Okay, like
What we need to do?
first, you need to pour this in your cup.
This is the sparkling water, right?
Yes, yes. So correct.
We put here.
Yes,
How much?
just the same like the tap water. This is your example. Okay,
So next,
so next, take this raisins and put into the tap water.
how much? 3.
How much can you put this a little bit? Wow. Not yet, but it's okay. Just put it. Yeah, yeah.
Wow.
Can you see the difference?
Yes.
Yeah. This is the normal one. Yeah. Show to the camera.
Yay.
The dancing raisins activity effectively illustrates key scientific principles such as buoyancy and gas release. By adding raisins to a glass of carbonated water, students observe how carbon dioxide bubbles adhere to the raisins, decreasing their density and causing them to float. When the bubbles pop, the raisins sink again. This visual and interactive experiment not only makes learning fun but also helps students better understand the behavior of gases in liquids and the concept of density.
Hi kids, so the next experiment is a magic floating ball. So the thing that we need is a ping pong ball and a hair dryer. Okay, next, so this is how we're going to open the hair dryer first. Then you put a ball. Wow, look at that magic floating ball.
Number 2. The magic floating ball activity is an exciting way for students to learn about air pressure and the Bernoulli principle. By using a hairdryer to levitate a ball, students can see how the fast-moving air creates lower pressure around the ball, keeping it suspended. This hand-on experiment not only demonstrates key scientific concept in a memorable way, but also encourages curiosity and critical thinking about the behavior of air and pressure.
We meet again, kids. So today we are going to do another experiment, which is floating egg in salt water. So the things that we need are
Water, salt, and egg.
So what are we gonna do is first just put the egg into the tap water without the salt. It's not floating because it's just a tap water. So what if we add salt into the tap water? Can you stir it first? Let's see. Is it floating or not? Oh my god, it's floating. Can you see it? Ta-da. See? This is your cup. Then the egg into the tap water. It's not floating, right?
Egg floating in salt water is the activity that is very straightforward yet powerful way to explore buoyancy and density. By experimenting with different salt concentrations in water, students can observe how the egg's buoyancy changes. This hands-on experiment vividly demonstrates how increasing salt concentration increases water density, allowing the egg to float more easily. Recording observations and adjusting salt levels further enriches the learning experience, promoting a deeper understanding of these fundamental scientific concepts. This activity not only makes science tangible, but also encourages critical thinking and experimentation.
Is the same force that keeps large ships afloat on water. Why does the raisin sink in water then? Well, because buoyant force is not the only force acting on it. The force of gravity pulls the raisin downwards. So sinking versus rising is a fight between upward buoyant force and the downward force of gravity. When gravity wins, the raisin sinks. On the other hand, when the buoyant force wins, the raisin rises upwards. We already know that more the weight of an object, more is the force of gravity. So heavier an object is, more would be the downward force. Bubbles in a carbonated drink are attracted to the rough surface of the raisins. When these bubbles attach to the raisin, they increase its volume substantially while keeping the weight almost the same. Therefore, the bubbles in the carbonated drink or the soda act like floating devices and increase the buoyant force on the raisins. As the buoyant force becomes stronger than the weight, it wins and the raisin rises up. But what happens that makes it fall back again? You guessed it right. When the bubbles come to the surface, they burst and the gas escapes in the air. With a decrease in volume, the buoyant force becomes weaker than the force of gravity. As gravity wins, the raisins sink. This rise and fall continues till there are enough bubbles in the drink which keep attaching to the raisins again and again.
lies in the density of water. But what is density? In simple terms, it is how much stuff in a given volume. The egg sinks in regular water because the egg's density is greater than water. But when you add salt, you're increasing the density of the water, making the egg float.
So that part is not so mysterious. The part that is mysterious and was to me was what happens if that ball gets off-centered? So let's say it moves to the left, and this shows the uncentered situation with the ball to the left and the stream of air going past it on the right. Well, why does that ball want to move back into that rushing air? You'd think that it wouldn't want to move back into that air and it would just fall off to the side. But what happens is that Bernoulli's principle comes into play. Over here there's a lot of air on the right side that's rushing past the ball. And Bernoulli's principle says that if you have a high velocity, a high airspeed, then you have a low pressure. So this air on this side of the right side of the ball exerts a smaller amount of pressure on this ball than the atmospheric pressure does on the other side. So this arrow represents the atmospheric pressure pushing the ball to the right, and this represents the less than atmospheric pressure that tries to push the ball back to the left. The atmospheric pressure from the left wins and pushes the ball back into the centered configuration, where now you've got equal.
The feedback for the magic of matter experiments that we have done, we would like to give the feedbacks, which is the first experiment, the dancing resins. Student will learn about how resins dance in the glass of water, and they will learn about the buoyancy and the law of gas release.
So for the activities 2, magic floating ball, today we create a floating ball using a hair dryer, exploring the concept, air pressure, and the Bernoulli principles.
And the last experiment, the egg floating in salt water. The experiment involved an egg flying in salt water, could test the buoyancy of the egg in the different concentrations of salt water. So the first egg without the salt, it will not float, and then the egg with the salt water, it will float. So kids will learn about the rate of fluids. So the things that we need is
Iya, tantangan.
Bisa belajar nih.
Sparkling water. Enggak ada. Minuman berkarbonat, tapi enggak ada.
Udah. Okay, so for the feedback about the magic of matters that we had done, the feedback from the activities that we have done, for the first experiment, the 1, 2, 3. Okay, next. Sakit, jangan aja. Tak, kita cakap dulu sebelum kita masuk macam let's do it together. Okay, masuk dulu. Maju dulu. We want to do it. Okay. 1.